Is finding your dream career feeling impossible right now? You're not alone. Welcome to Career Blueprint, the podcast that helps you figure out your next career move. We explore the trends in tech shaking up the job market, giving you the unfiltered advice you need, whether you're starting out, changing direction, or guiding someone else. Let's figure out what's next for you together. This is Career Blueprint. To give you a perspective on how long the idea of AI has been around, the term artificial intelligence came about at a workshop for scholars and researchers at Dartmouth College in 1956. Their big idea or theory was that every aspect of human learning or intelligence could be described and written out in steps so precisely that a machine could follow those written steps and simulate that human behavior. That was groundbreaking thinking at the time. Let's put this event into context. Imagine yourself back in the 1950s. There's no smartphones, no cell phones of any type, no internet. No one had a personal computer. And a lot of households didn't have a television. That's how far back we're going from a technology perspective. So the idea of a computer doing human tasks was revolutionary. Very creative thinking. Now, the AI technology that was in existence at the time of the Dartmouth workshop was pretty rudimentary by today's standards. It was primarily rule-based programming, meaning that a human had to tell the computer every step to take, every possible move or decision. The computer had no ability to think or reason on its own or do anything other than what the human told it to do through programming. An early example of this was a computer checkers game developed in 1952, shortly before the Dartmouth workshop. In the game, a human could play checkers against a computer versus playing against another human. The computer's gameplay was pretty basic at first. It could only follow predetermined rules and strategies programmed by the developer. And remember, the game of checkers isn't that complex in the first place, so this was very rudimentary. But things started to get interesting as the developers iterated. They changed the program so that it could do more than just follow instructions. It started learning from its experience. As the computer played more and more games, it tracked each board position it encountered, noted whether its moves led to wins or losses. The computer then used that history to gradually get better every time. Basically, it started learning from its mistakes. This was the beginning of what we now call machine learning, which is one of our 6 key AI terms we're going to talk about today. Machine learning is when a computer learns from experience or from large data sets, rather than relying on step-by-step programming for every possible task. Now, after that checkers game we talked about in the Dartmouth workshop in the 1950s, 2 significant technological developments occurred that made machine learning what it is today and gave us the second type of technology we're going to talk about, which is deep machine learning or just deep learning. The first big development was the introduction of probability and statistics into computer programming. This gave computers the ability to guess the most likely answers in a given situation. Instead of memorizing every possible input, like in the checkers game we talked about, these computer models could sift through huge amounts of data, spot patterns, and make informed predictions based on the information they'd already seen. This meant the computer didn't have to directly experience something in order to learn from it. Instead, the computer could learn simply from the data provided to it. For instance, a computer might predict when a piece of equipment at a power plant could fail simply by looking at how often its parts have been replaced. This introduction of probability and statistics into machine learning set the stage for what we call today predictive AI. The second development that advanced machine learning after the 1950s was the introduction of something called neural networks. neural networks are a computer programming way of mimicking the way the human brain works. Imagine a neural network as a kind of virtual brain made up of tiny building blocks called neurons. But instead of these neurons being made of biology like a human brain is, neural networks are just simply lines of computer code. Each of these artificial neurons or lines of computer code take in bits of information, do some quick math in an algorithm, and then pass those results forward to the next neuron. By stacking many of these layers together, computer scientists can create powerful models capable of complex tasks like recognizing faces in photos, understanding spoken language, or predicting trends by identifying patterns in unstructured data. The system builds up knowledge layer by layer, gradually improving its ability to make decisions or find insights. When we combine these elements together, machine learning, probability and statistics, and neural networks, we get the second type of AI technology we'll talk about today, which is deep learning. Now, deep learning is a subset of machine learning, but it's used for different tasks. Traditional machine learning relies on rule-based algorithms like the checkers game. So you'll see machine learning used in jobs that work with structured, smaller data sets where you use routine pattern recognition and repetitive decision-making. Think about jobs like data entry clerk, bookkeepers and entry-level accountants, proofreaders and translators, tax preparers, loan officers. In contrast, deep learning systems can take raw, unstructured data and autonomously figure out which features and relationships are important for making predictions or decisions. The layers of neural network nodes allow deep learning systems to create hierarchies among data for more nuanced decision-making. This allows the deep learning models to operate within more ambiguity than traditional machine learning, which relies on binary choices. You pick A or you pick B. Deep learning is how computers can create art, analyze human sentiment in a massive batch of social media posts, recognize human voice and speech patterns, and translate text in a natural human-sounding way. The full range of deep learning AI is still being explored, but it is showing promise for handling complex, high-value tasks like medical imaging diagnosis, first-year lawyer research and brief writing, entry-level software engineering, marketing and financial analysis, just to name a few. Deep learning AI is spurring a lot of the apocalyptic kind of talk we're hearing about today about AI taking over all jobs. But remember, it takes a while for deep learning applications to become commercially viable. Just because a computer can do something in a lab doesn't mean it's going to be doing your job tomorrow. It takes time to translate the computer ability into commercial tasks and then for it to be trusted by humans and to be implemented in the real world. This is not happening overnight to all jobs. For most jobs, you have some time to prepare, which is why we're talking together today. Let me just give you an example. Self-driving cars are powered by deep learning, and they have been around since Google introduced Waymo in 2009. But today, they're still a bit of a novelty in most cities, and they're not completely mainstream across the U.S. Adoption is slow, and plenty of testing is still going on. That means jobs like truck drivers, rideshare drivers, and chauffeurs aren't vanishing overnight. Now, the technology will get there, but as you can see, these big changes take time to become an everyday reality. As deep learning is tested in different applications, expect to see the biggest impact on jobs that analyze data, whether it's structured or unstructured, and jobs that do not have customer-facing responsibilities. So more to come on deep learning and jobs in future episodes. Now, our third type of AI technology we'll talk about is natural language processing. Going back to the 1950s and 60s, computer scientists dreamed about computers that could understand and even speak human language. In the 60s, a team at MIT developed the first chatbot, which was named Eliza. Eliza was set up to be a pretend mental health therapist. What could go wrong? You could type messages to Eliza, and it would reply almost, sort of, kind of like you were talking to a real person. If you typed, "I'm feeling sad," Eliza might answer, "Why do you say you're feeling sad?" If you say, "My mother hates me," Eliza could say, "Tell me more about your family." Now, Eliza didn't really understand what you were saying, just like chatbots today don't really understand. Eliza was simply following patterns and simple rules, looking for keywords and matching your phrases to pre-written scripts. The impact of Eliza was that, for the first time, it opened people's eyes to the idea that a computer could listen and react, even if it wasn't truly thinking. As AI technology continued to evolve after the 50s and 60s, researchers began to dream bigger, wondering if machines could understand the words, meanings, maybe even the feelings behind our language. This curiosity sparked the birth of our third type of AI we're going to talk about, natural language processing. Early versions of natural language processing focused on teaching computers to handle simple language tasks, like translating text from one language to another or responding to basic commands. At first, these systems relied on sets of pre-written rules put together by linguists and programmers, which meant they could only manage very specific conversations or answer pre-written questions. But as the technology advanced and more data became available, these rule-based systems evolved. By the 1980s and 90s, as machine learning was also evolving, computers could learn from examples and discover patterns in human speech and writing. Instead of being told every rule, a computer could pick up on a trend, like how words are commonly used together or how sentences are structured. It did this by analyzing massive collections of books, emails, and internet posts. That's why we saw so many disputes between newspapers and authors and tech companies. The tech companies were scooping up vast amounts of online content, sometimes without permission, to train their natural language models. Natural language processing started to become commercially widespread in the 2010s when chatbots became routinely embedded in digital websites, and also when Siri and Alexa were launched. Now, we all remember how bad chatbots were when they first came out. They were terrible. Terrible. But with the arrival of deep learning, computers are beginning to grasp the richness and complexity of natural human language, and they are starting to understand context, slang, and even humor. Now, the technology still has a way to go, but you can start to see how it could progress in the next 3, 5, 7, or even 10 years. So for now, natural language processing is primarily impacting jobs that require only fairly simple human interactions. Think about call center agents, telemarketers, first-level customer support representatives, medical transcriptionists. But as the technology develops, other jobs requiring more complex human interactions are on the horizons. Think about legal assistants, technical support specialists, online tutors, and content moderators. Jobs like that will also feel an impact.